Thank you. So this is actually, I think, my first IBL talk ever. And so I wanted to preface this by saying that this is based on one class that I taught once. So anything that I say is really just based on this one class. I'm going to start by telling you a little bit about my flavor of IBL, and then I'm going to get into the specific question of what happens when your class ends up being larger than you were expecting, and what are some things you can do. And also, I'll address some specific number theory stuff a little bit later. All right, so first off, my flavor of IBL, because IBL is one of these broad umbrella terms that could mean a lot of different things. So in my class, I spend the time on two different things. We have 2 days a week where the students work in groups on problems, and then we have 1 day where the students present the problems at the board. So there are no lectures in my classes, and the groups are actually assigned by me. I put the word engineered there because I do engineer the groups. I try to make sure that they're mixed ability groups. There's no like A student group or C student group. And I try to make sure that I'm sensitive about things like not having 2 really arrogant guys and 1 really timid girl in one group, things like that. So I do engineer the groups. I try to rotate them so that most people end up working with everyone else by the end of the semester. And I ended up converging on rotating groups every 2 weeks. And this was actually after some experimentation. So I started out with rotating groups once a week, and I found that students were having a hard time coordinating their schedules and trying to find time outside of class to work. And they actually preferred meeting, kind of rotating groups every 2 weeks. We found 2 weeks was just enough time that they got to know each other, they got used to working together, but they didn't quite get sick of each other yet. So we found that was a good length of time. In my class, textbooks and internet resources are explicitly forbidden. And we have a very strict honor code at Oberlin, so I actually am pretty sure that they follow that. I didn't see any evidence of people submitting things that seemed way too clever to be true. I do give them hints during class. So I will walk around and give hints, and the amount of hint I give is proportional to the amount of effort that they've put in. So if they immediately want a hint, I say, well, I don't keep thinking about that. If they've clearly been working on it all class period and keep kind of going in the wrong direction, then I'll give them a little bit of a bigger hint. And then finally, I do interject in student presentations. I try not to. I try to let the students jump in with questions for one another. I try to let the students sort of correct one another a little bit if there are problems. But if things are getting really off course, or if a conjecture is just completely wrong, I don't want them leaving the class period with wrong ideas, because I'm afraid this will solidify in their minds, and then they'll continue going through life with these false ideas. And so I do sometimes find myself jumping in, and I try to do it in the spirit of IBL. I try to say, well, I'm actually a little bit confused about this, and maybe I'll give a counterexample I've thought of and said, how do you sort of reconcile these things? But I do jump in. So one question I think that is in everyone's minds is, how do you sell IBL to students at the beginning of the semester, and how do you sell it to your colleagues if they're skeptical? And so the way that I sold it, and this idea actually comes from Ralph Spitzier, so I can't claim credit for it, was to sort of make it like a mini research course and sort of tell them that this is how mathematicians approach research. And so this course is really going to be kind of pretending to be a researcher in number theory for a semester and sort of seeing what it's like to be in my shoes, because I'm a number theorist. And so what I do is I give them problems where they have to make a bunch of computations, and then I'll give them some problems later on where they have to use those computations to make some conjectures, and then finally later on I'll ask them to prove those conjectures. And I kind of emphasize that this is exactly the same way that I approach my research program. Students work with one another as research collaborators. And sometimes the collaborations don't go so well. Sometimes some students are carrying the group and another student isn't doing their work. And when I say to them, I'm like, I've had plenty of collaborators who either try to do too much and leave me behind, or who try to do nothing at all. And so this happens in the real research world too. And so that's kind of how I help to reconcile this idea of working in groups, is I try to emphasize that this is good practice for the real world if you want to be a mathematician, or really if you want any other kind of job, this will happen. I do require the students to tech up their work, and they submit a final textbook project at the end of the semester. And in this textbook project, again, this is me sort of viewing it as like a research course. I grade them on both the mathematical correctness, but also on their exposition and the quality of their writing. And so I really do try to make it a course where I'm going to help them become better writers, better at explaining their ideas, better at connecting ideas by having some sentences in between the proofs and the statements, so you can see sort of that they can synthesize all this knowledge from over the course of the semester. And then finally, I actually made an undergraduate-friendly research seminar at Oberlin this past semester, and I required all of them to go to it. And so this is just my way of sort of showing them, look, if you become a research mathematician, we go to research talks, and this is a thing. And this was a little bit of my way, too, of sort of appeasing the people who were complaining that there weren't enough lectures in the course. Like, we didn't have any lectures in my course, but there were some lectures that they could go to if they really wanted to see lectures. Well, there they were. And so that was sort of a nice bonus feature. OK, so I said my class was larger than expected, and then I realized that probably a lot of you, your definition of large is maybe a little different than mine at Oberlin. So none of my classes look like this. But what I will say is that a year ago, when I was told I would teach a number theory course, I was told I would probably have about 5 to 10 students. And I was like, OK, 5 to 10 sounds really good. Is that too good to be true? And I talked to people who had taught the class before, and I found out that maybe it'd be more like 12. 12 was sort of the typical number in the course. And I figured, with 12 students, I'd get a nice cozy seminar room, and we kind of would all be buddy-buddy, and it would be great. Instead, we got 24 students, and actually 30 showed up the first day of class. But anyway, in the end, 21 ended up enrolling, and we had 3 auditors. And we ended up having the biggest lecture hall in the math department at Oberlin. So, again, this is at Oberlin. This isn't compared to other schools, but it was like a 45 or 50-person room, kind of narrow and long with lots of rows of chairs. Not ideal for IBL, not a lot of blackboard space. So I couldn't have them all kind of working up in little groups at the blackboard and then presenting their problems. I had to kind of, on presentation days, be very clever about having a few people writing things at the boards while as having other people, like introduce themselves to their future group members and, like do various other things. Like I was handing back problem sets and stuff during that time so people didn't feel like they were wasting their time. But I had to really be careful because we didn't have a lot of board space and we had a very suboptimal classroom. So some things that I did to get around this, well, first off, when I realized that I wasn't going to get this nice 5 to 10 person class, I was actually going to get like a 24 person class. I realized this a couple days before the semester started. And so I ended up making 2 syllabi, because I'm one of those people who views a syllabus as like a contract for the course between the professor and student. So I made 2 syllabi, one for the original plan for the course, and one for what I would do if it ended up being really large. And then on the first day of class, I brought both stacks of syllabi, waited to see who showed up. When I saw 30 people showed up, I decided to hand out the course syllabus for the big class. And so I really had no idea which of these 2 versions it was going to be until the day the first class started. And I did take a little survey, like how many of you think you might stick around, how many of you are just shopping, just to sort of gauge how big the class would be. And so my original plan was this. It was like, Wednesdays and Fridays, students would work in groups of 3 on problems, and I thought 3 was sort of the ideal group size. And then Mondays, they'd present what they had done the previous week. They would turn in their homework. And then I would give them back the previous week's homework so that they could look at what they had done and sort of revise any mistakes and get it ready for the textbook project. And then my homework policy was going to be, this was the small class, that they turn in individual problem sets. They work in groups, turn in individual problem sets, and then they turn in individual textbooks. And then every student would present in class every other week. So that was my grand vision for the course. With 24 students in the class and 21 taking the class for real, I didn't think I could actually do this. We don't have the possibility of graders for this class. It's a junior-senior level elective course, and it's offered every other year. So the people who had taken it in the last iteration had already graduated, so I couldn't get an undergraduate grader. And so grading 21 IBL problem sets every week, especially kind of at the level that I really wanted to be able to give feedback, I just didn't see that being something realistic for me. And so what I ended up doing instead was I had the students do group homework assignments, and they collaborated on these using a program called Share LaTeX. And so if you haven't seen Share LaTeX, I had it kind of on the computer to pull up, but I think given the technology issues I've had, I won't do that. But if you haven't used Share LaTeX, you should check it out. It's basically like Google Docs, where you can log into the system, and everyone has a different colored cursor. So you can invite people to be your collaborators, and you all share the same LaTeX document. And so the students would have their own colored cursors, and they could be editing the LaTeX document at the same time. And then they had this little kind of like AOL Instant Messenger sort of chat type window where they could be talking to each other about what they were doing. And so I did this because this allowed them to actually collaborate without physically being in the same spot. And so I think this is the only reason that this group homework ended up working in my class, because my students were really busy, and a lot of them were like visiting graduate schools and halfway across the country doing that on weekends and stuff, and so it just wouldn't have worked. So that was how I did it. And then to deal with the textbook project, each student turned in their own individual textbook project at the end of the semester. And you might say, well, if they had group homework, how was it that individual? Well, they rotated groups every 2 weeks. And they were expected to do their revisions on their own. So even though they had done the original problems as a group, the end textbook projects ended up being pretty different. So I didn't feel like it was just like I was getting all these copies of the same textbook. And then for presentations in class, I ended up switching the rule. Instead of every other week, I said at least 5 times over the course of the semester. And 5 times over the course of the semester, I ended up taking this in a very broad way where they didn't have to be physically standing at the board doing a prepared presentation 5 times. I also counted it if they raised their hand in class and asked a good question of a classmate, or if they jumped in with a suggestion when a classmate got stuck, or if their classmate was putting up some conjectures and they had other conjectures they wanted to add. So any of those things counted towards their participation. And actually, many of my students far exceeded the 5 times. But this was just my way of, in a large class, being able to have them talk on a regular basis, since, with 21 students, and I was only getting through maybe 5 problems a class, it just wasn't going to happen otherwise. Okay, so I wanted to do sort of a model version of my classroom for a few minutes. And so I made worksheets for all of you. And I wanted you to see sort of how I construct my IBL worksheets. And let me see how I'm doing on time. All right. So I think we'll have time for about 5 minutes or so of group work. And I'll just go ahead and hand stacks of this to pass down. So I would say go ahead and get in groups of 3 or 2 if you can. Do you want one to keep? Oh, to hand it out. Thank you. And so what I wanted to say, so don't do this whole problem set. So the goal is I want you to see on problem set number 6 sort of how I structure my problem sets. And so notice that I'm defining n factorial, and I'm giving them this problem number n2, which says how many zeros are there at the end of 37 factorial. And then on the back, so the problem I want you to do is problem set number 7, problem number n2. And so that's the one, yes. Oh, I can just do, here you go. There you go. n2 on set 7. So set 6 is just to show you, oh, sure. Set 6 is just to show you how I structure these things. So set 6 is something people would do on a Friday, and then they'd present on Monday, and then we'd start set 7 on Wednesday. So this is after they've sort of seen how to do set 6. Yes, yeah, the whole 15 minutes. And like I said, we usually get through about 5 problems by the time that they ask their questions and sort of contribute to each other's thoughts. Okay, so if this is my class period, you guys would have 50 minutes to do this problem and a few others. And if you didn't finish it in class, you'd get to take it home and finish it up for homework. And if you finished early, you'd get to get started on the starred problems, which are their homework problems. So everyone has something to do. I want to go ahead and just kind of spoil the surprise for you because I only have 5 minutes left in my talk. So hopefully the conjecture that most of you are starting to get towards is that if n is 4, that's the weird one. That's where n minus 1 factorial is congruent to 2 mod 4. If n is composite and it's not equal to 4, then hopefully you saw that it's actually n minus 1 factorial will be 0 mod n. And if n is prime, then you should have noticed that n minus 1 factorial seems like it's always minus 1 mod n. And that's what people know as Wilson's theorem. And so I'd have students do this in class, and if they had some wrong conjectures or if it didn't seem like they were kind of converging on something, I would have them do more examples until there was sort of an obvious table of a lot of zeros and a lot of minus 1s, and then they'd say, okay, maybe this is true. And so where's this going? Well, set number 9, which would have been the following week, so a full week after they did this problem set and have already presented on this problem set, then they finally get this statement, and they would know from the conjecture that they made that this statement is actually false. And so I give a lot of these sort of false statements to my students, and the reason is because I want them to look for subtleties. I want them to think, well, is this true for any integer n, or just for certain integers n? And so I make them actually find a counterexample if it's false, and then salvage it to a correct statement. And so probably the correct statement they would give is if n is any prime, then p minus 1 factorial is congruent to minus 1 mod p. So that's where that was going, and then they would prove it on set number 9. And so this is how I kind of build things up. And you'll notice on the problem sets I gave you, it's not like contained in specific units. It's not like you have one unit on, like multiplicative units and multiplicative orders, or one unit on quadratic reciprocity. Instead, I kind of build all these concepts simultaneously. And so each week you're kind of getting a little bit further on maybe 6 different tracks of ideas. And so that by the end of the semester, it all kind of culminates in things like Mobius inversion, a proof of quadratic reciprocity, the proof that the units mod p are cyclic, things like that. But it takes a while for things to kind of build up. And I sort of like this idea of having them do several things at once so that it kind of all comes to a head at the same time. So I wanted to kind of end my talk by mentioning a few things that the students have said, and then also sort of what I would do differently when I teach this class again. So as you can see here, this was one of the negative comments. Apparently, this student felt that if the smarter people do all the harder problems, then the others are not learning. And the person said, I felt I put in a reasonable amount of time, but I only did approximately 1/3 of each assignment, and they would prefer a standard lecture format as a result. So this is one of those cases where over and over semester, I kept saying, you shouldn't just be doing the third that you write up. Even if you only write up 1/3 of the problems, you should be doing all of the problems. You should be having scratch work for how to solve all the problems. I just only care if you tech up your portion in your group. So that is sort of one downside, is really getting students to actually listen to you and not just split up the work if they have group homework assignments. Another comment, which I sort of viewed as mixed, so the students started out being kind of skeptical about IBL and said it started out rocky. And the biggest issue they had was with group members not doing their part of the work and that inducing stress. But then they found that over the course of time, they really did enjoy the class. And so this part about group members not doing their portion of the work was a problem that I faced all semester. I think some students didn't really want to take an IBL course, but had been planning to take number theory for the past 2 years. And so even though I was teaching it as IBL, they took it anyway, but they hated that it was IBL, and they didn't want to do all this work outside of class. So my students spend on average 10 hours a week outside of class, which I don't think is unreasonable for a 300-level course. Finally, we have this comment, which is that the student felt they learned more from this class than any other class they've taken at Oberlin, and they think they're actually going to remember this content. And so I picked these 3 comments because these were all expressed by more than one student. And so these were sort of some of the bad sides of doing IBL, but also some of the good sides. I feel like the people who really invested themselves in it learned the subject very well and are going to remember it. So the final question, what would I change if I teach this again? Well, I would love to tell my department just to cap the class at 12. I don't think that's realistic. So more seriously, I would advertise the course in advance as an IBL course. Like, either put that in the course catalog, or if I can't do that, at least have signs everywhere kind of making it clear to people, if they sign up for this, this is how it's going to be done. And I'll offer to talk to anyone about what this means. I would like to, one of my biggest issues that I had with a larger than expected class is those Monday presentations in that really long, narrow classroom with all those people were very intimidating for the students. It took about 8 weeks until they really got comfortable with each other, 8 weeks out of 13. And so I would split this Monday presentation section into 2 lab sections. It might mean me sticking after class. So in other words, teaching 3:30 to 4:30 like I normally do, but then also teaching 4:30 to 5:30 and having this extra hour. But I think if I did that, I would have about 10 students per section, and that would be a lot more sort of friendly and amenable to having this kind of camaraderie that I want in these class presentations. And then finally, I would want my students to fill out a sort of a bi-weekly self-assessment where they could also assess how their group members are doing. But I really found that actually self-assessments, the students were surprisingly honest about how much they were putting in terms of work and in terms of whether they were meeting their responsibilities. And so the point of this would be to cut down on dead weight people in the groups, and it'd also be to get people to be constantly working on those revisions for their textbook projects, because some people weren't doing that. And so I'd have a question in there where I'd say, are you up to date on revisions for your textbook project, just to kind of emphasize that they should be. So these are the things I would change. And that was all I wanted to mention, so thank you very much for your attention.
So we're into the... I'm Martha Siegel. I just wanted to ask if you could describe again briefly the textbook project and its purpose.
So the textbook project, basically they take these problems as they work on all semester. I give them copious feedback, and then each individual revises based on my feedback. And then there were kind of 2 parts to the textbook. So one was just that they revised the problems they've done to learn from their mistakes. The other part was I made each of them write a special section of the textbook that was focused on one specific set of topics, and they had to kind of show how those topics were developed. So the point of that was really synthesis and understanding how everything fit together.
That's what I thought, because I was going to ask about the synthesis. Thank you.
You're welcome. And if people have more questions, feel free to track me down. Thank you.